Hey everybody, Dr. A here, and in this video we're going to explore yet another example of matrix multiplication. So here we are given the following information. We are told to compute the product A times B, and matrix A is a 2 by 4, 2 rows, 4 columns. Matrix B is a 4 by 1, so it's got 4 rows, but it's got one single column. So we sometimes call this a column vector or a column matrix. So solution. Let's go ahead and write this out. First, can we actually perform this operation? Well, we'll say write A in the subscripts. We know that that's a 2 by 4, and then next to that we're going to say times B. And we know that B is a 4 by 1. And so it's going to give us some product, let's call it maybe C, just given a name, matrix C. And so that size is going to be a 2 by 1. So you may be wondering, how do I know that? Well, remember that in order for you to be able to multiply two matrices together, the number of columns in the left matrix has to be equal to the number of rows in the right matrix. And then when you multiply these two things together, the product will have the number of rows that the left matrix has, and it will have the number of columns that the right matrix has. That's why this product that we're calling matrix C, it has 2 rows and 1 column, a 2 by 1, okay? So let's go ahead and write this out. We're going to say A by B is going to look something like this. I'm going to rewrite this nice and neat. You want to write all this down in your notes, okay? Take notes, write everything down. That's the only way to learn. So we're going to say that's matrix A multiplied by matrix B, 1, 2, 0, negative 1. And then this product, of course, is going to have 2 rows and 1 column. So let's open up a bracket here and see what happens. So remember, if you haven't seen my previous videos, take a look at those as well. We're going to multiply the rows, each row of the left matrix, by each column of the right matrix. And we're going to be multiplying their corresponding entries. So the first entry in my product is going to come from the first row of A multiplied by the first column of B. Now, there's only one column of B, but that's still going to be the case. And we're going to do it entry by entry. So I'm going to say the 1, 1 entry here multiplied by the 1, 1 entry here plus the second entry of row 1 by the second entry of column 1 plus third entry of row 1 times third entry of column 1 plus fourth entry of row 1 times fourth entry of column 1. So we're going to say 1 by 1 plus 0 by 2 plus 3 by 0 plus negative 1 by negative 1. And all of these things that we're going to multiply and add together here in a second are going to be the first entry in the first row and the first column of the product C, okay? Now, what do we do about this, about the second row? Well, remember, we're going to multiply row 2 of the left matrix by column 1 of the right matrix, okay, which is column 1 is the only column there. So we're going to have 2 by 1 plus 0 by 2 plus 1 by 0 plus 4 by negative 1. Close that bracket off. And so finally C becomes, and I'm going to evaluate all of these products and adding additions. So that's 1 plus 0 plus 0 plus 1. So that should give me the number 2. And then down here, 2 plus 0 plus 0 minus 4. So that should give me negative 2. And that is my answer. And sure enough, it has 2 rows and 1 column. So one more time, make sure we understand this. You multiply the rows of the left matrix by the columns of the right matrix, and you just go systematically one at a time, multiplying corresponding entries and then adding as appropriate as you move forward and then complete this product. Okay, so that's going to be the end of this video. Please hit like and subscribe. Thanks for watching.